Hello everyone, today I'm going to solve a Leetcode problem, transpose matrix. So this, I have solved this problem when I was in a TV station. So we have given a 2D integer array matrix, return the transpose of the matrix. So transpose of the matrix is a matrix flipped over its main diagonal, switching the matrix's row and column indices. So as you know in mathematics, so we know that transpose is just flipping the rows of a matrix to a column, right? So how do we flip the rows of a certain matrix into a column? So we one thing we can do is we fix the certain column and certain column of this matrix and take the all the numbers in this column as a row. Like let's say we are at the column 0 and we'll take all the numbers in this column and take them are as a row for our flipped matrix. So the thing we are going to do is just like that. So we'll fix our row and we will iterate over each row and take the number in that column and take that array of collection of numbers and collect the numbers and take them as a new row for the transpose matrix. So I'm going to solve this problem this way. So as I have said, like for example, for this one, I iterate over this column. I will take 2 minus 10 and 18, and I will take them as a new numbers in new row. Like it's gonna be like this one, and like as you can see, like it's gonna be they are going to be a new numbers in the new row, and I will fix my column to the next this one, and I will take all the numbers in this column, treating over all over the rows, and collect these numbers as a new row for this one transpose matrix, and also I will fix my column at this position, and then I will take all the numbers and take them as a new numbers at a new column, right? A new row, right, for the transpose matrix. Then that means it's easy, right? We will take the rows become a column and the columns become a row. That's transposing, right? It's easy. So what I'm going to do is first I need to know the length of the column, right? So it's gonna be a matrix, right? So it's gonna be a matrix, and n is just and also I have to tell you like the time complexity would be like of n times n, right? Because we of n times n, the number of rows times the number of columns. It's gonna be like up to in the power of 5. So n times n would definitely pass, right? So and the numbers are they're either negative or positive, doesn't matter. So it's gonna be length of matrix at 0, and we iterate first the columns because I need to fix the column. As I say, like I need to fix the column and iterate over each row, right, and collect the numbers. So in range of n, and for each row, I'm going to in range of m. So let's say I have a new row, right? Let's say new row. Let's say I can say row. Let's say new row. Like I'm building an array transpose matrix, or let's say transposed. It's gonna be like this. So I'm going to find the new row for rows for transpose matrix, right? So one thing, what I'm going to do is new row dot append numbers at matrix of row code, right? So I'm going to fix the column and iterate over each row and append the numbers. Then append transpose dot append the new row, right? Then I'm going to return transposed. It's gonna be the solution is gonna be like this one, and the time complexity is just of n times n, the number of rows times the number of columns, and space complexity. The space complexity is just gonna be of let's say, since I have this new row, so it's gonna be the maximum size of this row is gonna be the number of rows, right? It's gonna be m, and the maximum number of numbers for adding to this new row is gonna be, for each column, it's gonna be okay. Let's say we'll have we will add all of the numbers in this array for each iteration, for each iteration. The space complexity is just we'll add m numbers here, and for each iteration it's gonna be okay. So the space is just wouldn't be, because we are just we are assigning and we are recreating a new array each time. And space complexity is just okay. Creating a new array wouldn't we are creating a new array each time, but we are not keeping the old numbers, right? We are adding them to this answer, because the answer array is not going to be considered. So we are not going to consider for a space for this one, but we have to consider for this. So I think this would be is gonna be of the number of, because we are just creating each time a new array, creating each time a new array creates a new space, a new but since we are not going to use, we assume like the GC will remove them. For this one, I am going to say the space complexity is of the number of rows. This is gonna be like of m, right? So this is all the solution. Let's test the code and see what's going to happen, right? So let's submit it and see what's going to happen if it works for. So as you can see, it passed. So thank you very much.